I like to get paid, that's why I work every day. I'll be making money till I'm in my grave. Don't care what they say, I'll buy time with my money. Laughing to the bank cause it's funny. The money keep coming, I manifest it. Sing these lyrics and you'll get it. I'm the bank, come invest it. I get tracked and I have it. Money finds me attractive. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but this beat lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. I'll do the work, yeah, I'll do it till it hurts. I'll invest in my future, I'll invest in the purse. I wanna be so rich, life changes, and I don't ever think about how much I just pay it. Yeah, it's the dream, the American dream. Live on top, don't stop till you got everything. But there's balance, cause this life is a challenge. You gotta live in the now while building up the talent. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but this beat lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. It's not about the destination, it's about the journey. So keep working till it's hurting, cause that's when you start deserving everything you want, everything you need. Trust the process, yeah, you got this. Keep on working till you bleed. Yeah, I've been there, yeah, I've done that. 10 long years of breaking my back, but now I'm up here, never looking back. I got more dreams that I wanna go attack. Keep on going, keep on moving, never give up. I'll keep going, I can prove just what I'm made of. I got that fire in me, got that desire in me. I'm never tired, I'll be pushing till I'm finally free. I was made to break away from the pack, to challenge, to fight, and to carve my own path. This world wasn't made for the weak, they don't last. Survival of the fittest, so be vicious and attack. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but this beat lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. I like to get paid, that's why I work every day. I'll be making money till I'm in my grave. Don't care what they say, I'll buy time with my money. Laughing to the bank cause it's funny. The money keep coming, I manifest it. Sing these lyrics and you'll get it. I'm the bank, come invest it. I get tracked and I have it. Money finds me attractive. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but this beat lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. I'll do the work, yeah, I'll do it till it hurts. I'll invest in my future, I'll invest in the purse. I wanna be so rich, life changes, and I don't ever think about how much I just pay it. Yeah, it's the dream, the American dream. Live on top, don't stop till you got everything. But there's balance, cause this life is a challenge. You gotta live in the now while building up the talent. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but this beat lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. It's not about the destination, it's about the journey. So keep working till it's hurting, cause that's when you start deserving everything you want, everything you need. Trust the process, yeah, you got this. Keep on working till you bleed. Yeah, I've been there, yeah, I've done that. 10 long years of breaking my back, but now I'm up here, never looking back. I got more dreams that I wanna go attack. Keep on going, keep on moving, never give up. I'll keep going, I can prove just what I'm made of. I got that fire in me, got that desire in me. I'm never tired, I'll be pushing till I'm finally free. I was made to break away from the pack, to challenge, to fight, and to carve my own path. This world wasn't made for the weak, they don't last. Survival of the fittest, so be vicious and attack. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but the speed lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. I like to get paid, that's why I work every day. I'll be making money till I'm in my grave. Don't care what they say, I'll buy time with my money. Laughing to the bank cause it's funny. The money keep coming, I manifest it. Sing these lyrics and you'll get it. I'm the bank, come invest it. I get tracked and I have it. Money finds me attractive. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but the speed lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. I'll do the work, yeah, I'll do it till it hurts. I'll invest in my future, I'll invest in the purse. I wanna be so rich, life changes, and I don't ever think about how much I just pay it. Yeah, it's the dream, the American dream. Live on top, don't stop till you got everything. But there's balance, cause this life is a challenge. You gotta live in the now while building up the talent. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but the speed lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. It's not about the destination, it's about the journey. So keep working till it's hurting, cause that's when you start deserving everything you want, everything you need. Trust the process, yeah, you got this. Keep on working till you bleed. Yeah, I've been there, yeah, I've done that. 10 long years of breaking my back, but now I'm up here, never looking back. I got more dreams that I wanna go attack. Keep on going, keep on moving, never give up. I'll keep going, I can prove just what I'm made of. I got that fire in me, got that desire in me. I'm never tired, I'll be pushing till I'm finally free. I was made to break away from the pack, to challenge, to fight, and to carve my own path. This world wasn't made for the weak, they don't last. Survival of the fittest, so be vicious and attack. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but the speed lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. I like to get paid, that's why I work every day. I'll be making money till I'm in my grave. Don't care what they say, I'll buy time with my money. Laughing to the bank cause it's funny. The money keep coming, I manifest it. Sing these lyrics and you'll get it. I'm the bank, come invest it. I get tracked and I have it. Money finds me attractive. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but the speed lit, so I'm going off thoughtless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. I'll do the work, yeah, I'll do it till it hurts. I'll invest in my future, I'll invest in the purse. I wanna be so rich, life changes, and I don't ever think about how much I just pay it. Yeah, it's the dream, the American dream. Live on top, don't stop till you got everything. But there's balance, cause this life is a challenge. You gotta live in the now while building up the talent. I'm the type to make commas, turn a profit. I'm the boss, Willy Wonka, but it ain't chocolate. Yeah, I'm just being honest, I work for this shit. I'm usually modest, but the speed lit, so I'm going off thought. flawless, talking my shit. Yeah, I'ma be the hottest designer in drip. I'm just coming with the rawness. I gotta admit that I'm usually modest, but I work hard for my shit. It's not about the destination, it's about the journey. So keep working till it's hurting, cause that's when you start deserving everything you want, everything you need. Trust the process, yeah, you got this. Keep on working till you bleed. So keep working till it's hurting, cause that's when you start deserving everything you want, everything you need. Trust the process, yeah, you got this. Keep on working till you bleed.
Alright, so let's see if this one is working. I just need to do a little bit of an audio
journey. So keep working till it's hurting, cause that's when you start deserving everything you want, everything you need. Trust the process, yeah, you got this. Keep on working till you bleed.
Everything is working correctly. Alright, so let's see if
Test.
this one is working.
Hey, what's up?
Need to do a little bit of an audio
journey. So keep working till it's hurting, cause that's when you start deserving everything you want, everything you need. Trust the process, yeah, you got this. Keep on working till you bleed.
Everything is working correctly. Alright, so let's see if
Test.
this one is working.
Bitaxe.
Hey, what's up?
Need to do a little bit of an... Okay, seems like the audio is working correctly. Hey guys, welcome to this live stream. I'm one Clue, also named Lars, and today we have two special guests here. We have the father of the Bitaxe project, that's called Scott. He's called Scott, and we also have Jonathan with us. He is from the Central, and today's topic is all about the Bitaxe. Today we want to discuss a little bit what this is, and we want to get a little bit into soldering. So the first thing I think we need to do is to introduce you both to the audience. So Scott, would you love to start and introduce yourself?
Yes. Well, first of all, thank you, Lars, for having me on here. This is pretty cool. Excited to see people stoked on the Bitaxe. My name is Scott. I'm the instigator of the Bitaxe project. Been working on it for several years now, but yeah, it's finally come along. It's finally working now. We've got a significant groundswell of excitement around it. So pretty excited to be here.
Great, great. Lovely to hear. Jonathan, let's get forward with you.
Yes, so I'm Jonathan. I'm the founder of Decentral. We founded on the 6th of October 2016, and we've been looking in all the ways we can help the pleb miners get into mining. And the Bitaxe is something we started to really put our eyes and our in our hands on since the beginning of the year, and it really just escalated since the Canadian Bitcoin conference, where we made a workshop for soldering these.
Yeah, we've seen some tweets about this, so it looks really amazing what you have done there. Appreciate it.
Yes, that is amazing. I was seriously impressed when I saw that workshop.
Well, I'm glad you liked it, and really, I'm really impressed by the work that Open Source Miners United and yourself has done, and the speed that you guys are going. I'm just trying, to keep up with the pace.
It's quickly going forward. That's really a thing here, especially in the Bitcoin mining process, that getting used to all the things and figuring out what to do with it, and really open source everything is a quick pace, I guess.
Absolutely.
Let me quickly switch over to another scene.
Yeah.
Absolutely, yeah.
Well, yeah. So I guess in summary, the Bitaxe is an open source Bitcoin ASIC miner. So yeah, like I said, I've been working on this for several years. I kind of had the idea to make a solar powered Bitcoin miner several years ago. Started digging into it and how to most efficiently make a solar powered miner, and kind of like had the unfortunate, I guess, realization that there wasn't really any open source information in the ASIC mining world. So there wasn't anything for me to just kind of like take and run with or to start building on. So I kind of had to like go back to, like first principles, like how do these ASICs work? And more even low level than that, like what's their physical dimensions? How do I solder them? What do the pins do? How do I connect? So I kind of dove in that rabbit hole like 2019, I guess. Started screwing around with the S9s and the chips, the BM1387, which is the ASIC from those. Started screwing around, made a bunch of PCBs, like probably a half dozen like prototype PCBs trying to get this to work. There's a little bit of information on them out there on the web, but not much at all. There's like these repair guides from Bitmain that are very vague, and there's a couple other people screwing with, but nothing super open source. So started reverse engineering it. Finally had some luck with the ASIC out of the S9, the 1387. Finally got that kind of working. Posted about it online on Bitcoin Talk. Got a couple people interested in it, and a couple people wanted to start helping out on it. And so then about that time, I switched to the 1397, which is the ASIC in the S17, because that miner had been released, and it had been long enough that those chips were actually getting to be affordable. So we switched over to that, and pretty quickly we're able to come up with it's called the Bitaxe Max, but that's the one you have there, the green board on your desk there. That's the Bitaxe Max, which is based on the 1397 ASIC from the S17. And so
see if I can quickly try to zoom in there a little bit so that the viewers can see.
yes,
So
nice.
they can see the little marking of the BM1397. And
Yeah, so that's version 3.2. We went through a couple revisions there, but I think and so kind of the interesting thing here was just posting fully open source hardware, firmware, software, and actually open sourcing the design process too. Like everything, we're talking about the Open Source Miners United is a Discord group that got founded sort of around this. Obviously embraces all different types of miners, but at least in the beginning, very focused on the Bitaxe. And all the designs are out there. Everything's out there. So this guy, who I only know as Developer Algo on the Discord group, actually he came over from Bitcoin Talk, but he was early in on it, and he decided he wanted to make a bunch of these, and so he did it. That's totally cool. That's like we talked a lot about it, but I encouraged him to just do it and put it together, and he did. And he made, I think, 200 of those. He calls them the job it. Put his name on it, which is totally awesome.
yeah.
And he put them together, tested them all, and sold them. I don't know how many he sold. I think a lot. But that's what you have there. And that was kind of the first opportunity for people to. I think that was the first opportunity. Maybe Jonathan can correct me if I'm wrong there, but I think that was the first opportunity for people to buy them. But
I believe so. Yeah, he had his batch 200 units. I have the same information, and I believe, I at least saw him at the same time we had this intention to bring it forward. So I believe he was first.
Okay, but then Jonathan came along right in that same time frame. I think you were pretty early on too in the process, and picked up the design and ran with it, and took your sort of manufacturing abilities and retail sales and kitting, and made these things available to the masses, really, because all I did was post the designs. And I think, as we're about to see here, it's a complicated build. It's really difficult to build.
In the current stage, it's really complicated. And by the way, for all the viewers out there, if you want to get a little bit more used to it, or want to know a little bit more about what we're talking about, in the video description you will find a link to the GitHub of the Bitaxe project. So if you want to take your time and read through everything, there is everything described in this GitHub repository. So just in case you miss anything, you will find a lot of information on this GitHub page. Scott, may I ask you something? A question that I always heard about, or that I always get asked, is how do you even reverse engineer this ASIC mining process? Like, how do you figure out which kind of pin you need to use on a PCB to get a connection, especially with an ESP32? Like, this is one of the most asked questions I get when I talk about the Bitaxe. And yeah, reverse engineering, as far as I know, is not really a easy process and needs a lot of time. So maybe you can give us a little bit of a hint about how you did it.
Sure. Well, my background is in electrical engineering. For my day job, I build a lot of circuits, a lot of PCBs. So I'm pretty familiar with how these things, in general work. So that helps. But as far as reverse engineering the Bitcoin mining ASIC specifically, it was a long process. I started and stopped several times, but really the first thing to do was to get a hold of the chips themselves. Luckily, there's a healthy miner repair industry, and so they sell spare parts of all types. And so I could actually get a hold of the bare chips, like brand new ones, unused. So I got some of those, and then when they came, I put them under the microscope and very carefully measured the bottom, right? Because there's no indication of like the size of the pins on the part itself, like the distances between them or anything. So I very, very carefully.
Sorry for interrupting you, but just for the viewers, like, I do have a do-it-yourself kit currently here, but we will get into this in a second, just to get you guys an idea of how tiny those things are. I do have one ASIC chip right here, and I'm not sure if you can even see all the pins on it, but this thing is really tiny, just to get an idea on what we're talking here about. Sorry for interrupting.
Yeah, no, that's good. Like they're really small. So yeah, I measured it really carefully. And translated that into my CAD software, where I started laying out a PCB. My first PCB was just a breakout board. It had all the pins, broken out to bigger connectors, so that I could just plug it into some like logic analyzer and oscilloscope, and just start kind of playing around with it. But we had one thing that really helps is we have those repair guides from Bitmain. And so for the older chips, they don't do this anymore, but for the older chips, it calls out which, like, the name of the signal on each pin. So I was able to get an idea, what's power, like what's serial data, what's clock, all those sorts of things. And that was really helpful, really, really helpful. But I guess funny story, in the beginning, I measured those pins and I made my first board. You can see all those teeny tiny little pins on each side there. And I made it and I put it together the board, and it didn't really work. Like, not at least how I expected it would work. But it kind of did. It was strange. It kind of worked, but not reliable, and it was super frustrating. And months went by of me just banging my head on it, like, why isn't this thing working? And then I got out the calipers again, and I was 0.02 millimeters off on the pitch of the pins. I had just assumed it was an even number, 0.5. And so I went with that, but it's actually 0.48 millimeters pitch.
Wow, that's insane.
And so, yeah, so just that little difference was causing it to actually kind of work. Like, I think some of the pins were connected and some of them weren't. Mm-hmm. And so it kind of worked. Once I fixed that, then it actually started working really, really well. But first step is get all the mechanical dimensions of the chip itself, so I can make that footprint that you see there and put it on the board. Then combine that with the information, the sort of vague information in the repair guide, and that lets me, tells me what the power pins are, what the serial pins are, and then taking a look at actual S9s and how they're connected and what they do, led me to do some, increasingly more correct circuit boards to analyze how it worked. And then actually for the S9 chip, the 1387, and part of the 1397, we have open source software called CG Miner that I could look at and see how, because that includes a driver for those ASICs. So I was able to look at that and see, firmware wise and register wise how they communicate with those chips. So getting that going, doing a little bit more poking with a logic analyzer on an S9, and then on a 17 got us to the point where we are now, which is the like on a traditional miner, you have the control board, but our control board is that ESP32, which is that sort of silver can looking thing there. So that's our control board, and it's running firmware called ESP Miner, and that's what communicates with the chip and sends it work. So I had a lot of help on that. A couple smart firmware engineers joined up to help me develop that, and yeah, I mean that rapid pace that you're talking about, it certainly wasn't rapid in the beginning, but once this just groundswell of interest came and engineers started kind of jumping on board, then the development pace was very quickly, and we got it to this point now.
Yeah, I think there's even like a picture on Twitter, or I don't know where I saw this picture first, but the process or the revisions that you did from 2019 till today.
Yes.
You will see the progress. Like most of the progress has been done in the last, I would say, in the last year probably. It took so it really took a long time to figure out everything and how it is working, how you need to connect all those pins together, and getting the ESP to properly connect and setting up the right lines to interact with the ASIC chip. And now that
the progress is
yeah.
I was just going to say that the progress has been exponential, where it started off really slow because it was just me. And then, because it's open source, people started jumping on and working together, and sort of the progress. Yeah, it's gone absolutely exponential because of open source. I really think that that's how we make progress quickly.
Yeah, insane. I really appreciate your work that you did, and it's really a project for the open source community. It's really lovely to have such a nice thing in here, and being able to raise the middle finger, I guess, or I would say a little bit, to all those big ASIC manufacturers and saying, hey, we can do this as well. Probably we will use your chips, but we figure out how to do it. And that's I think a good part that we need to do and need to take action in. Otherwise we will be controlled by like 4 companies, and decentralization is nothing that you can compare with 4 companies, I would say.
Yeah, I think there's also just huge interest. Like, people want to be mining at home, and they don't want to necessarily run a 3 kilowatt, hair dryer in their room all the time, right? They want something approachable, something they can try, because I just think there's a lot of people interested in mining who just haven't been able to do it because there isn't like home mining products. So I think,
especially if you're talking about this tiny device, like this is just drawing around 15 watts out of the wall. I'm currently running this at 240 volts, so I'm not sure how much it will draw in US with 120, but it's close to nothing, like compared to a big S19 or the newer ones, the S21s that will be released very soon. This one, sure, it doesn't have all the hash power that the big ones got, but it's something to get started and to get into this kind of lottery mining, solo mining, whatever you want to call it.
Yes, that's the hope, and it's very exciting to see more and more people getting in on it.
Yeah, amazing.
And if I can just chime in quick, for the open source, I think there's many ways that people can contribute, and maybe we want to stress that a bit to your viewers, that like really anything that people will do will help the project. So just talking about it and doing a live stream like you're doing is actually contributing to the project. Also, the documentation on the GitHub is a bit messy, so I'm sure there's some people that could put some order in there. So there's a lot of stuff that can be done to help the project.
Yeah, I believe so as well. Like currently we do
Absolutely.
have a couple of different repositories. We do have the Bitaxe repository with all these files and schematics that you need for the Bitaxe to understand what's going on a PCB and how are all those parts connected. So the Bitaxe repository on GitHub that I posted in the video description down below is basically the hardware part. When it comes to the software that you need on this device to run actually Bitaxe, you need to hop into another repository that's called ESP Miner, as Scott stated, and it's also available on GitHub. So now that we kind of know about what this Bitaxe is and getting a little bit into this open source understanding and why we kind of need it, let's talk about this do-it-yourself kit that we do have here. I got this little package from Decentral. Jonathan sent me this over. So basically we have a PCB, this one here, in this purple color. There are a couple of parts soldered already onto it, but in this, I believe this is 3D printed, this enclosure, right?
Correct, yes.
Yeah, it's looking amazing. We do have a couple other parts that we need to solder onto this board. So this is basically a small step on a do-it-yourself action that you could take. You could either buy a pre-assembled one that you will just plug in into your wall and then you can configure it, or you just say, okay, I want to get a little bit more used to soldering and understanding the electronics and what they are doing, and then you just get this this little box here with a couple of parts in it that you need to solder onto this board. And that's kind of also the mission that I want to do today. I'm not sure if we will finish this. If this stream will take a little bit too long, I will just make a video about this and don't waste all of your time. But yeah, I would assume to get a little bit of your information how you would start actually with the soldering process. I have bought some flux and some soldering paste to get all the parts onto this PCB. And maybe you want to talk a little bit about this, Jonathan, how you would start such a project and getting used to soldering.
Yeah.
Actually,
So
if I could real quickly, Jonathan, I just wanted, maybe you could talk a little bit about this this Bitaxe, because I think this is a bit of your design here, and
Oh yeah,
you guys obviously made this kit. I'd be really curious to know about what's going on here.
yeah, well, so in this version, it's really just a small contribution from our end. We actually put the USB on the BM3097 design as well, and the small buttons, on the bottom right, left. So we added that based a bit on the BM1366 model that received those updates. And it's a way for us to also start to tinker, because that's one of the goals for us, is to really get that understanding as well. So as we go and get more understanding and get more expertise and more understanding on how all of this is working, well, we're able to export that knowledge to our customers and to other miners that are interested all around us. One first thing we did, so when we did that workshop at the conference, we obviously asked every participant if they had some experience with the soldering or whatnot. And what we quickly realized is that people really overestimate their capabilities on doing that kind of stuff. It's really small parts, like you mentioned. So over the time, what we did is we managed to find a sweet spot between the missing parts that you'll get at most major, PCB manufacturers, such as a GLC PCB or a PCBWay, and to find like different kind of parts as well. So what we want is to also give an experience where you have to solder different type of chips and get that different, that the different feeling of all of those different chips. So even though now some of the chips are available and some batches we'll keep those same missing chips on our PCB, because that's what we found to be a good sweet spot that will enable people to still, test their skills and really get some more, capabilities with the soldering with their hands. And if you can build your Bitaxe, well, then you can start to look into stuff like the ASIC repair industry. So it's really connecting a lot of stuff that we're really doing ourselves. And since we have that experience and that understanding, we're able to export it in I would say user-friendly package.
Yeah, amazing. Like really giving the guys or the people that are ordering from your shop the opportunity to dive into soldering, I think is quite amazing. I'm not really used myself on soldering, and I did a couple of soldering projects myself, but nothing really that is comparable to those tiny things that I need to solder onto this PCB. But I believe it's a great way of getting the people the information to understand how you actually what you actually need to do to be able to mine with an ASIC Bitcoin, and yeah, I think that's pretty a nice
Yeah, and just
idea.
electronics in general.
Of course, yeah, of course.
And so, one more thing we did is on the upper right corner, we have pins now for the LEDs that we put inside the mini bit version of the Bitaxe. That's also available on our shop. And that mini bit version is really like a, I'd say more like a collection tool. So it's really if you want to have like that nice little conversation starter, sorry, in your lounge, and so it's really something that catches the eye. So you have that those LEDs you can control with your cell phone with Bluetooth. You can have it like sound activated, stuff like that. And we're also working now on another other version that could be maybe USB powered through power delivery.
That's pretty amazing. Like having the opportunity just to plug in your USB-C cable and getting this
Yeah.
thing up and running is really amazing. Because in the current iteration, you need a 5-volt cable like this one and some sort of a
Yeah.
bell plug to get power to this PCB. But having the opportunity to get this running with just an USB would be really amazing.
For the getting started, us personally, we mostly use the hot air station. I know you've mentioned when we talked that you're more with the iron. So with the iron, I wouldn't I don't have the best advice. I would say it's you really have to figure like the good quantity of solder paste. I'd say put the soldering paste on the PCB and then use your iron on your pads instead of wetting your iron. And really the main difficulty I find with this is really just figuring out the right quantity of soldering paste to use, and that's something it's not something you'll have to figure as much when you're using the stencil. So it's a bit of a disadvantage against doing the whole like PCB, but obviously you would have to solder all those small resistors and capacitors where it's not really exciting to install 100 resistance and capacitors. So in
Yeah.
a sense, what we wanted is to remove that cumbersome step of the process.
Yeah, like when we're talking about soldering all the parts, um, from my opinion, I'm most worried about the ASIC chip in general because you have all those little connectors that you see on this PCB, and I do have a iron and I also have a hot air station. So I mean, we could try it with both, but what I think like all the viewers are also a little bit concerned about is how would you actually get this ASIC on and be sure that all the connections are correct. Um, like,
Oh,
is
well,
there
really,
anything
it's
that you could destroy? Like, let's say, for example, by putting a little bit too much solder paste on it, you connected two pins. Will this actually destroy the ASIC? I don't know.
that would create a bridge, obviously, between two pins, and it wouldn't work, but it wouldn't destroy it. So you can just, remove the ASIC, clean the pads, and restart again. So there's no. What you have to be careful about is not to scratch the PCB too much. So if you go with an iron, there's going to be more risk of that. If you go and if you go too hard on the PCB. Or the pins, you don't want to remove a pin or to scratch the board and then have a bridge that's a bit embedded in the board. So that would be the main thing you have to be cautious about. But really, the ASIC chip, in my opinion, is one of the easiest thing to install on this. The real trouble for me is the U9 chip that's under the Bitaxe.
The U9, let's see. So this should be this one here, right?
Yeah, yeah, that one is funny.
Yeah, I see. It's probably not visible in the camera, but it has like 8 or 9 connectors, and they're really, really small. But by the way, is there even an orientation how I need to install all those things? Like I see
Oh
with the
yeah, of
ASIC
course.
chip, I see with the
Yeah,
ASIC
so
chip
the
you have some
the
sort of
ASIC chip, you're gonna
orientation.
figure it out. The ASIC chip, you're gonna figure it out with the footprint of the chip, so that's
Hmm.
easy there. But for the other ICs, you can look. There's a small dot. It's not necessarily super obvious, but when you look at the chip, there's gonna be a small dot at one of the corners, and you do have to adjust that small dot with the dot that's on the PCB. So there's going to be one for the chip and one on the PCB as well, and that's going to give you the orientation to install.
Let me see.
Yeah, we can see it there.
It's really tiny. I'm sorry, I'm a little bit
Yeah.
shaking.
Yeah, it's really tiny. That's a standard thing in electronics. You have that's called the pin 1 marker, and so there should be, like Jonathan said, there should be a corresponding dot on the PCB, and you just need to line them up.
Okay, let's see. Just to figure out where this is. So we do have a couple of markings that I can see. So for example, down here we have this C28. So basically this is some sort of a naming that you do on this PCB to know where you need to place one of those little thingies on, right?
Correct.
Yeah.
So maybe Scott is more is better to go on and explain what's the naming scheme on those electronic boards, but you're gonna have different letters and numbers with different meanings.
Mm-hmm.
Yeah, those are called reference designators, and it's probably just tradition, but capacitors start with C, resistors start with R, diodes start with D. For some reason, ICs start with U. Test points are TP. So there should be a consistent pattern of those letters, and then after each letter is a number, and each one has a unique number. So, you see C7, C11 there. I can tell you, just based on those reference designators, those are capacitors. And yeah, the PCB CAD software relies on those reference designators also to keep sort of consistency between the PCB file and the schematic file and the BOM, which is the bill of materials.
By the way, let's quickly answer one or two questions from the chat. The first question that I currently see is, do you offer Bitaxe fully assembled on your website? I guess I can quickly answer this, but Jonathan, do you want to answer it?
Oh yeah, so obviously we do offer a do-it-yourself kit for those that want to take care. But if you want to just grab one of these, we have them available as what we call the vanilla version. So the vanilla version is the one you're seeing there. Is really the stripped-down version to have the lowest cost Bitaxe, and you start with that base. Some people might want to change the fan because it's not we have some that shipped with a dual bearing fan, but normally it's shipping with a brushless fan, which is pretty cheap. So if you want to change it for a noctua fan maybe and really have a good silent fan, you can do that. We also have the mini bit version, which is a more premium version. In there we'll put the dual bearing fans and the LEDs I was talking about, and it's in a small nice 3D printed shell that we've designed, so some people might also like it in that shell that reminds the Antminer S9. And we also have the 1366 version that's only available as a mini bit right now, and we're coming with the vanilla version, but we don't want to so we're limited in resources. So we're 13 at Decentral, and we also have the other queues that we still have to cater to, and we do want to put more attention on this, but we do it carefully because when you're operating in Bitcoin since 2016 like I did, you know that you have to pick up on those trends very carefully and really slowly increase, because if you go too quick and then you're gonna get burned when the market change, and it can change and swing quickly. So we really, that's our way to manage, is really to go slowly and carefully. So the Bitaxe 1366 will be coming as a vanilla version as well.
Amazing. So, and for those guys who didn't notice this, in the stream description, you will also find a link to the shop of Decentral. So just to check it out, you can click the link in the description. It will bring you directly to the vanilla version of the Bitaxe with the BM1397, so the S17 chip. But as he stated, you will probably find in the near future also the Ultra version there.
Yeah.
So what would you assume? Would it be the best case to just start with the ASIC first and see if we can get this sorted onto the PCB, or shall we start with the other parts and do the ASIC as the latest one to figure out if the connection is all right? Because I think what
That's what I do.
yeah,
When I make them, I start with the back.
you start with the back, all right. So
Yeah.
let's see, we do have a couple ones, and I believe it's not really interesting for all of us to watch me all day long just soldering here a couple of parts into it. So I guess we will just solder one or two things and maybe the ASIC on the front side to get a little bit of an understanding to this, and I think then we can call it a day. Like, yeah.
That's good.
Okay, so let's see what we have. So this one is the kit that you get if you order this do-it-yourself kit. This is the newest version. This is the version number 2. I believe the first version that you offered on your shop was basically all the parts, and you need to solder all the parts on it, right?
Yeah, and it was all in Ziploc bags with labels and was messy, chaotic. So we really just came with that box even without telling nobody, and just started shipping those, and really got a good response from people that it's much clearer, parts are nice, and some of them were second time buyers, so they could compare against the first order they received and tell us how it improves for them. So really that we've kept that box, we've kept the same price, we've kept everything as is, and we're now rolling with that version as a do-it-yourself kit, and we're not touching it anymore.
That's amazing. I really love the idea. And the first time I opened the package and I saw this 3D printed enclosure for all the small ICs, I really smiled. It was amazing. Like, everything can be 3D printed nowadays, and it's really looking so awesome. I really appreciate it. So I do have started my hot air gun, and let me quickly put in one of those tips. I don't know if this one is the right one. I just ordered a couple of soldering, a little bit of soldering paste on Amazon, and also the flux. So I'm not sure. Should I start with putting on some flux on one of the soldering points, and then start with the soldering
Your solder
paste?
paste is Your solar paste is most likely going to include some flux inside it, so you won't need to use the flux at this step. So if you
Mm-hmm.
just want to kind of thin your pads, and it depends on how you want to do it, so you can just put some soldering paste and then start to just directly put the chip on top of it and start, bring your hot air gun to the part you're soldering, and
Yeah.
it should place itself and come all together pretty much by itself. What I always tell the technicians that start with us, and that are getting started, I always tell, let the heat do its job.
All right, all right. So what I would assume is just by starting with some big ones to get used to it. So I would start with the L1, and also in here, does this have some sort of an orientation that we need to put in? Because I cannot see any point on this one.
Correct, and that's a good observation. And some of those parts won't require an orientation. The same goes for the really small parts, so the resistance and the capacitors. Most of them won't require orientation. But there are some special capacitors, like the one just under the part you're going to be installing. I believe that one is C28, and this one has polarity, so plus and minus.
C28. So it's
Oh
this
no,
one.
that's not the one. I mistake it. So it would be the capacitor just under the L1 part. I just don't
Ah,
recall
this one,
the.
this tiny one here.
That seems to be the crystal.
Okay, so probably, yeah, I'm not really used to electronics. I'm sorry about this. Um, Probably this one, the DI. I'm not sure. Like we have the
Ah,
46
this
here,
one. Yes, yes, exactly. C46.
C46. So let's see. This is this one.
Yeah. So this one you
Ah,
can see there's a white marking there. So that would be your positive side.
okay, okay. I see. So the white marking would be on the positive side. So I believe like this one, like this. Okay.
Correct.
Okay. All right. So, but I would assume let's start with the biggest one that I could find here, just to get used to it. Let me quickly heat up my hot air station. Okay. So I just put on some of the solder paste. It's really it's really weird, like having some sort of a syringe here and using this. But let's see if this works. I never did this. So
Yeah,
bear
no
with
worries.
me. Let's see if we can get someone.
That's what's actually amazing. See, is to do it the first time and to get that understanding on how those really all those electronics are working that we're using every day and that we never really truly hone until we can put our hands onto it, right?
Yeah, right, right. Like you never really get used to it, and you don't really understand what's going on in there. I probably put on way too much of the solder paste on it, but let me
Oh,
see if
that looks actually good. Go with that and let's
let
see
me
what
see.
happens.
Yeah, let's see. So let me scroll in a little bit. It's probably getting loud here because I do have the heat gun now running. I have this at 160 degrees. So let's get this a little bit more hotter. And let's reduce the airflow a little bit. There we go. So let's see what's happening here. I'm not sure if we can.
Just go ahead and eat it until you see it becoming, really silverish and shiny. So you can see it's starting to, the flux inside the paste is starting to come out. And see it's starting to gray out now. So just give it a bit more time and it should turn to silver.
All right, let's see. Maybe I need to adjust the heat a little bit. I'm not sure.
It's
Like this,
possible, yeah. What's your
this.
temperature right now?
My temperature right now is 160 degrees Celsius. It stays like you need it
Oh, yeah, yeah, yeah.
138, but maybe
Yeah,
I
but
need a little bit more.
go higher because your hair, it's coming out. First of all, it's always imperfect, the hot air stations, and it's coming out and already losing a lot of its heat until it reaches that pace. So you want to go ahead and go a bit higher.
Ah, there we go.
Oh, yeah.
There we go. Yes, that's beautiful.
Amazing. So let's see on the top part as well.
I would probably hit it just after you see that, like hit it a little bit more. Once
A
it
little
goes
bit more.
silver, then it'll suck
Yeah.
underneath. There
Amazing.
you yes. Oh, that's gorgeous.
It's quite nice. It
See,
feels
so
satisfying, really. It
does
feels
all the job.
satisfying.
Yeah, that's it.
Amazing. Like, and that's basically the process. Of course, you in a perfect situation, you want to have some machines that are doing this for you. But like the whole experience about the Bitaxe project and getting this and building this together is like getting used to soldering and what it needs to, or what it takes to actually build such a device. To, I would even say, relive the experience that you had, Scott.
Yes. Yes. I mean, it's fantastic. Is this your first time soldering?
It's my first time soldering something on such a PCB. When it comes to soldering, I just soldered a couple of cables. Let me quickly zoom out. I'm just tinkering a little bit on like getting a solar nerd miner, like this pleb miner that we talked a little
Awesome.
bit about.
Okay.
I'm just
So
tinkering
this is
about
your
this.
first surface mount. Your
Yeah,
first surface
yeah,
mount
that's my
soldering. Oh,
first
this is
surface.
so amazing. Love to see it.
Amazing. So, okay, now we finally sorted the biggest part on it. Maybe we go along with the smaller one that you mentioned, this one that we have here. So we do see, let me zoom in again a little bit. We do see that we have some sort of an orientation. So this is, well, there we go. This is the plus side, and we need to put it on this plus side, I guess, or I believe.
Correct, and you can see it also. There's a marking on the PCB. You can see the little plus sign there.
Yes.
Yeah, so you just put it on that side. So you can go ahead and look where. So whenever you're working on a PCB, not just that project, but whenever there's a polarity, you're gonna see that small plus sign on the PCB as well.
All right. So let's see if I can get some of the solder paste on it.
And in this case, you're gonna want to be cautious to make sure that your paste doesn't go under and bridge under the chip.
Okay, and how do I make sure that I don't bridge it?
So it's just going to be about the quantity and observation. So you can go ahead and test what we have here. And if it doesn't work, no matter, we just remove it. We'll remove some tin and go ahead again.
All right, let's see. So I put it on here, and now let's see. I need to reduce a little bit the air because I don't want to blow away this little chip. So let's see. There we go. And there we go. I'm not really sure if it, like, Okay, so you probably just soldered on and you tried to look at it from different orientations, like figuring out did it bridge or not.
Yeah, you can do that, and you could see it if it bridges under. So it doesn't look like it from a quick, like from where I can see, it doesn't look to be bridged.
I mean, could I use some sort of a multimeter or something out to figure out if it bridged or not?
Absolutely, yeah. You could run continuity. I'm not sure if that part should be continuous normally, though. Maybe Scott remembers.
It should not. It should not have continuity across there. Or if it should have a very high resistance reading across that chip.
Okay, so I would measure what, like resistance?
Yeah, you could put it on the resistance setting and then put your probes on each side of C46.
So let's see, I do have my multimeter here with me.
Yeah, that's
Okay,
good.
so we put the plus sign on plus and the negative on negative, and we do get 10 to 11 kilo ohms.
Yeah, I think that's good, right? If you had a short, a bridge, it would be a very low number, like 1
Yeah,
ohm.
like putting it together.
Yeah, the thing that makes this complicated is now it's soldered to the circuit, so you have to consider everything else that's in the circuit.
Ah, okay.
And also your multimeter will be slowly charging up that capacitor.
Oh, okay, interesting. I didn't know this.
Yeah. Yeah, I mean I think, it's just a reality check to see, did you get a big number like you got 11,000, which is fine, right? If you had a short, it would be like, 10 ohms or less.
Ah, all right. So let's see, we also have this chip Q2. So I see that we do have Q1 and Q2 in the same one here. How would I figure out which one is which, like out there? Yeah.
Oh, so they're both the same. You just have a different orientation, and those are MOSFET.
Okay, so I need to put this, let's see if I can get a better focus on this. So I need to put this small dot on the orientation of the board where we can see the number, like the Q2, right?
Correct. Yeah. So the
Okay.
first one would be the pin one would be on the upper. Sorry, on the from what I can see here
I
from
see. There's a dot. There's
lowest. Yeah, lowest.
yeah,
Right.
I'm
Yeah.
sorry. So there's the dot on the board that I can see, and I will put on the dot of this that we see here on the dot on the board. So I
This
will-
one's kind of a fun one because there's those 2 dots there, right? There's a dot next to each one.
Yeah,
So
but when I take a look on the downside, I can tell how I need to put it on. Like just from my watching on it, how would I probably need to solder it onto? Because I see there are some connectors on the bottom part, and there's nothing connecting
Right,
down
yes.
to the upper part, and the upper part is a whole complete part. So I would assume
Absolutely. Yeah.
that I need to put it on in this orientation. But what
Yeah.
I
That's
also
another way you can
see
always.
is like this white line here. Is this some sort of separator just for the visual aspect?
yeah, those lines are to help you orient the part when you're soldering it down because you won't be able to see the pads. They're
Okay.
underneath. Those white lines kind of help you to make sure that the part is sitting on the pad properly.
How much solder paste would I put in on something like this Q2?
For the ground pad like this, I think is not too bad, and you can go and make a small line, a quick line, really not thick, a thin line on the small parts there, and when you heat it, it's all gonna go at the right spot.
Okay, let me see if I can get this, and then I try to take out my hot gun and just to preheat it, and then put it on the chip, maybe.
Normally, you could go ahead and just install the chip, heat it, and it should all go at the right spot.
Okay, let me see if I can get this. It's really amazing to do this like the first time. Okay, so I now take the chip, I put it on here.
Yeah.
And now I should be able to just blow some hot air on it, and it should do some of the magic, right?
And larger parts can take more time to reach the temperature, right? So it can take some time sometimes.
Sure, of course. Like they need a little bit more. So now we can see that everything. Uh-huh. And now we do have this tiny dot here, like this circular dot. Can we just get this
That can
off?
happen. So two options depends on what you're seeing. If it's not connecting and all your other connectors are well tinned, you could just use an iron and correct whatever you need to correct. If it's still warm, you can go ahead and remove it with the tweezers like you did, but don't do it when it's cold because you could just break and go with the pad.
All right, all right. Okay, so now we did the first one. Now we can obviously do the second one as well. So we put on some of the paste on the lower section. Then we can also put some paste here. And then I can just take this chip, figure out where is the point. So I see the point on the top here. I also see that there's also a point, and I just place it on it.
I would say that, you know, you're doing good. One thing I might be tempted to do is give it maybe another second. Once you see that solder go silver and start
Yeah.
to flow underneath, keep the heat on it for maybe another second or so,
Okay,
because we really want that solder to reflow onto the pads.
Okay, let me see. I need to orientate this a little bit better.
Yeah.
Now. Let me see if I can. It's so funny. It's like magically going into the right direction.
Yeah, that's the best thing.
It's really amazing. Okay, let me get those off. Also this one.
So most people, that's the struggle, is they'll try to fight against a chip when they're eating it and when they're starting out. But you have a very good end because and very good eyes because you're doing exactly fine. You let the heat do its job, and that's really what it's about. When you let the heat do its job, like you already have 80% of the jobs done.
Amazing, amazing. So I do see that we do have the U8. So this one, we obviously soldered now a couple of parts. We started with just 2 soldering points. Now we had like multiple soldering points. And now I would say let's go a little bit further and take the U8 because I see that's like to the left on here and it has like
Mhm.
a huge amount of connectors. So let's see if I can find the U8. It's in here. So this one has some little legs. And I see it doesn't have really a dot on it, but it is kind of dotted on
Yeah,
one
yeah.
side.
It has one on the bottom left right now of the chip.
So yeah, and I can see here's also a dot, so I would assume the orientation is like this.
Correct.
Okay, so let's just do a little bit of a line on both sides. And just for the viewers, I'm sorry if you're typing out anything in the chat. My monitor is a little bit away, so I cannot read your questions if you have some. If one of you both guys would love to hop over to the stream, just mute it, and maybe you'll
Yeah.
find 1 or 2 questions that you want to answer. It would be amazing. While I'm doing this boring part here. So let me see.
It's
what
fascinating. It's mesmerizing to watch.
So let me see. I need to do a little bit more on the right hand side. There we go. It's a little bit too much, but let's see. So what would I do if I have too much on it? Let's see if this is too much, because yeah, I don't really know how I could get this off. Just like heat it again and try to get everything off.
There is one question in the chat that's asking if they can be used in a public pool and not just as a solo mining pool. And yes, so that's a good question because I know some of the people that might be watching right now have some nerd miners, and nerd miners can have some trouble connecting to most major pools because the hash rate is too low. Well, in this case, since you have an ASIC, the hash rate is going to be just high enough so you can connect to those pools. Now, you do have to keep in mind that it's a device where you have all the PCB and all those components with just one ASIC. So the return over investment, pool mining with this device is not going to be fabulous, but it is possible.
So let's see.
There's another question. It says, so for me to do this, I wouldn't need a soldering iron. You should probably have a soldering iron. In fact, I think you can get hot air guns that also have a soldering iron attached. But for some of the through-hole parts, I think you're going to want a soldering iron.
So let me see. What I see now on the current process is that I do have some sort of connection here, and I'm not sure if all the other parts connected correctly. So I tried to move it a little bit while holding my hot air gun on it. So it's pretty good. Now the viewers can actually see what would you do if something like this happens. What would I do now? Like, should I use an soldering iron now?
If I'm not sure if the alignment is appropriate right now, I'm not seeing correctly. But if you think the alignment from what you're seeing with your eyes is good, then you can just go ahead, put some flux on there, use your iron, and just gently go and try to grab the tin, those tin balls that you have there, and just gently go and let the flux bring that tin to your iron, and it should all correct itself.
So
Again, let the heat do its job.
So I should use my iron now, and I should also use some of the flux.
Correct.
So let's see.
We weren't using flux before because you have some on the solder paste, but now that you've heated it, that flux is gone.
Okay, so now I have a little bit of flux on this. Let me... Oh, I need to plug in my soldering iron. 1 second. There we go.
I just wanted to point out that it's pretty awesome that you have that part. It's a sign that you're in good hands with Decentral, because that part right there, the INA 260, is actually really difficult to find, and a lot of people haven't been able to get it. So you should feel good that you have that included in your kit.
Yeah, there were some of the hard to source parts, indeed.
So let me see. Let me quickly clean the tip.
And if you have those copper, I don't know how to call it in English, that copper thing you can go and clean your iron. You can do that repeatedly to remove the tin from your iron and then go back to remove the ball.
Let me see if I get this. Seems to be really hard, like it's not really sticking. Oh, now I got a little bit. Let me see, I do have some, like those brass or copper ones.
Yeah,
exactly.
Yeah, you want to clean the solder off any that's come off on your iron. You want to clean it off in there. And then
let's see if I get this. I'm also using.
You can also, if you have a good amount of flux on there, you can try and drag it across the rest of the pins to spread it out.
Let me see if I can get some flux on it. Like, this is pretty new. I never used flux in my life before, because I didn't know what it was doing, but I watched a video about what it was doing, and it kind of feels amazing how this is magically doing all the things that you want it to do.
Absolutely.
Amazing. I really
Flux reduces the surface tension of solder.
I really appreciate that you both guys bear with me and guide me through this process. I never did this, and I hope that some people will find this interesting and obviously learn something about how to get into this.
Oh, there's at least seven people right now that are appreciating what you're showing. So I think it's relevant to go ahead and proceed.
Of course. So let's see if we can get this away.
And actually even 16, because I didn't look at the right metric there, but you already have 16 people that thanked you for that stream.
Amazing. Always lovely to have a little bit of a good community that is appreciating what you're doing. So let's see. It seems like I'm not really getting it out there. It's good to have this kind of issue. Sure, it currently bugs me, but it's good to see what
Yeah,
you
so
can do.
one other thing you can do is just take your hot air station, remove the chip, try to remove the tin from the legs with your iron again, but
All
now
right.
you won't have to be as careful because you won't have the PCB that you can damage, and then just go and slap it back to the PCB.
Let me see if I can do this. So let me see if I can grab it. I'm trying to. There we go. Okay, so let me quickly hold this into the camera so that people understand what the issue is. Let me see if I can find the camera. Here we go. So we do have this chip here, and the issue that we have is that I have a couple of solder paste on the bottom right, and it's connecting multiple legs. I also see that I do have this on the top right. So this is the issue that we want to fix. So we want to get this solder paste off this tiny IC and solder it on correctly. So let's see. I would assume I need to clean the PCB in the first place, right?
Yeah, you can always, it's always a good practice to use a cotton and alcohol to remove all that, hold flux and have some fresh flux for reapplying.
All right, all right. So let's see if I can get this. Off here. Maybe I need to use some copper wire to actually get this off. I do have some lying around here. Sure, most of the things that I currently use are not in the common household, but I hope that you guys find this interesting, and maybe we'll get a little bit into soldering and understanding what we're doing here. So let's see. Why I'm trying this is just because I saw this on another YouTube channel that they just used some copper wire, some copper to get rid of the solder paste that's left on the plate. And there you can see it's actually going away. It's amazing. It's working. YouTube is working. Amazing.
It's the best school there is now.
It really is. It really is. So let's see. I need to reapply a little bit of solder paste on it. Let me quickly take a look on the IC.
Do you have tweezers? Can you feel like if you just go and really gently let your tweezers go on the pins, can you feel the dents? Because if you can feel them, I'd say it's thin enough.
Yeah, I was going to say the same thing. I don't think you need any more solder paste.
Okay, let me see if I can get this into the camera. Could be that I don't need any more solder paste, yeah. I see that there's no solder paste on the left-hand side, so maybe I need a little bit on this side.
Really, I think for those pins, I think all I can see, if you can feel the pins on your PCB with the tweezers, then just remove the bulbs you have on that chip, put some flux, reapply, and I'm pretty sure you're gonna be good. And if you have like one pin that's missing tin, then you can just go and wet your iron, and not put solder paste on the whole thing, but just wet your iron and go to that pin and eat it until it's fed.
Okay, let me put on some flux on the PCB. So some here, just a good amount. And let's try
Before
this.
reapplying that chip, don't forget to remove that bridge you have on the chip though.
So I need to remove the bridge that I have on the chip.
Yeah, that would be the goal for us to remove that chip, is to be able to go and remove that
Okay, let me see.
bridge without being on the PCB, so you don't damage the PCB, and then you can get back to reinstalling that chip.
Okay, let me see. I do have some third hands here that I can use. Let me see. If we get a look, there we go. Whoop. There we do
One
see.
thing
Yeah.
One thing you could try. Here's an idea. So you had the solder braid, that little piece of copper.
Yeah. So I
If
could, I
if you
could
put,
use this one and try to scrap it away, alright?
yeah, I might be tempted to put your chip down in the flux there next to the part, and then uh, hold the hot fluxy solder braid on there. You got to be really careful not to bend those pins.
Mm-hmm. Seems like I got the bridge removed. Alright. I see that there is one other bridge on the top here as well. Should I clean this as well, or do you think?
Yeah. Try to remove all the bridges so you don't have any trouble when you're installing on the PCB.
Okay. Hoppala. You really need to be gentle with this, right?
Yeah, gentle and really careful when installing. Really, you want the heat to do the installation. You don't want to have any manual interventions to do.
All right. Let me see. It's really hard, and I'm trying to understand what kind of work you guys are doing. This is really rough. This is really rough. Okay, seems
It's
like
clean now.
now it's really hot. Oh, yeah, kind of hot. Let me see. Yeah, I do see one bridge, and on the other side another bridge. So let me see if I can get this on the camera. I do see one bridge on the top.
Oh yeah. Yeah.
I mean, shouldn't the flux move in the right direction now? It's just
It's
tiny.
possible, but it could be just enough of a blob to stay stuck between.
Okay, I see. So I should try to remove this as well. Also, I do see that I have a bridge down here. I guess I would just try to put it on and try to re-solder it onto it. Maybe it works. Maybe we are lucky today. Let's see.
Yeah, I would try putting it back on, and if the bridge stays there, there's a technique using that solder braid that you can do to get off the bridges. This happens a lot on those DFP packages.
Okay, let's see. Yeah, you really need to make sure that you put it on the right way. Like, those legs are so tiny, you really need to be careful. Okay, let me see. I need to move this a little bit more down so that the people get a little bit more of a view. So let's see if we can heat this up and if it does its job. Seems like it kind of seems like perfect. Let me see. Ah, now I see there's one bridge. The other side looks perfect, but there's one bridge. It's the same one. So we do have
Try this. Try this. Put a little bit of flux on the pins,
All right.
and then take the that solder braid, the copper mesh stuff, and put it. Yeah, put that on there, right over the top of the. Yeah. Now, whoop,
It's sticky.
sticky stuff. It's actually tree sap. It's based on tree sap. Okay, so now take your solder braid, put it on top, and then put your soldering iron on top of that, and carefully push down.
1 second.
Mm.
1 second. Do we have any other questions in the chat? Because I really need to quickly reduce the amount of my heat that's coming out of my Bitcoin heater.
Let's see. You're the Bob Ross of circuit boards. That's awesome.
So I'm back.
Hi from Spain. I think that says hello from Mexico.
Okay, let's see. So I do have the copper one right here, and let's take the heat gun again, and let's see. So you mentioned just put it on there.
You use your soldering iron. You still have your soldering iron hot?
Yeah, no, I don't think so. Let me see. No, it takes a couple of seconds.
Yeah, heat up your soldering iron, and then you want to just use the soldering iron to gently push down on top of that braid, and it'll just suck that solder ball right up into the braid.
All right, let's try this. Sounds like a good idea, because I have no idea what I'm doing here.
Even when you're doing reflow in an oven, you get these bridges like that, and I end up going back and doing that a fair amount. It's just the flux is what's going to cause it to suck up into the braid.
All right. Yeah, it seems like it's like a millimeter that I missed the right spot. Really like a millimeter, and this is insane. Those tiny like.
This is all part of the process. What you're going through is absolutely normal, and that most of the viewers that are watching now that want to buy a do-it-yourself kit should really understand that this is a normal, installation. You're actually doing very good, and so it's part of the process to go through those troubles installing those different chips, and that's what we want. We want you to be able to get that experience and understanding of all those different, designs and yeah, so really normal.
It looks a little bit better. Let's see.
We have Miguel that's asking where we can buy a kit with all the pieces. So if you want as is kit, as shown in the video, you can come to decentral.tech, TECH. But if you want to go ahead and have a unpopulated board, then you can just go to the GitHub and download all the files that are required there, and go to PCBWay or GLC PCB and have them build your PCB unpopulated. And in this case, you might want to get it with a stencil as well, so you can have the appropriate amount of soldering paste on each component. And then you need to go and have a shopping cart for each of those parts on the Bitaxe.
Yeah, it's tricky, but I'm getting there. It's not that easy. It's really a process of learning.
But you just tap and really leave your iron there. Don't move too much. Just leave it there a bit. Let the heat do its job, and then come back up and see how it is under.
So let's see. Yeah, this is probably a little bit boring for most of the people, but it's still a bridge. This is insane. Okay, so let's try the other side. Maybe we have more luck over here. Because I saw that we do have a bridge also on this side.
Yeah, I think the viewers are appreciating, so don't worry about it too much. It's really good work.
So let's see. So I see that we do still have a bridge on the top left and the bottom right. Probably what I should do is get this off again and try to clean it and then get it back on again. It's probably the best idea, because otherwise I think this is not really working, because those copper wires that I do have are from some LoRaWAN cables, from some cables for radio frequency stuff that I used to do.
So you go with what you feel comfortable with is the best trick, really. So there's a lot of ways to go and proceed with that. So you go with what you feel comfortable doing. If you go over your comfort zone, you might create more damage and then have a bigger problem on your hands.
So interesting. Now I released it and it released all the bridges. So let me see. I quickly clean it with the copper wire that I have laying around. So this is nothing special. I never bought this copper wire from a seller or anything. It's just the copper wire that I had laying around. Let me see. So the bridge I can see is on the PCB. Seems like I cleaned it now. Yeah. Okay, now I try to put on the IC again, and then it should reflow correctly. Should I put on some flux again? I'm not sure.
Yeah, go as a safety, maybe put a small amount of new flux, yeah.
Okay. Let me see.
And don't worry too much if your board is all sticky. You can always clean it once you're all done.
Yeah, I do have some. Let me wipe this off quickly. Yeah, this stuff is really sticky. Interesting.
Yeah, yeah, yeah.
Yeah, you can see all the hairs that are now on the board. Damn it. Let me quickly inspect it. Maybe I can get the hairs off of it. Okay. So, let's put on some flux again. So a little bit over here. And a little bit over here.
It's better to use your solder paste sparingly to avoid bridges, Guido Vames is asking. So yes, you want to really apply a thin layer of soldering paste when you're going to solder some leg like that. And when you're going for ground pieces like we did with the MOSFETs, you want to have a bit of a thicker layer to really make sure that everything under is well fed.
Let me see, I do see a small blob. I just want to get rid of it, so not create another bridge. No, seems better now. Okay, let me try to put this IC back on. Now it really looks kind of a little bit messy, but I hope that it now works and we don't have a bridge. Oh, it's hot. Fuck.
You can always take your time to really align it before starting to eat, and that can be when you're more elite. You can go ahead and eat and place it at the same time. But at the beginning, just go ahead, place the part, make sure everything is well centered, and then start applying your heat. No problem. And taking some time might save you time at the end of the day.
Yeah, as you can see, I'm a little bit shaking. Those things are really tiny. Aligning them is really...
Yeah. Absolutely normal. It's part of the process, really.
Let me take a look on the camera. This looks aligned right now to me. Let's see.
Yeah, looking good.
I do have some goggles here.
Scott, maybe I'll let you answer the next question of Guido Vames.
Sure, yeah. Let's see.
Yeah, I'm sorry for using you to answer the questions.
Oh, who created the actual board that you're soldering onto? Well, I guess I created the first version of it, and this one is modified by Jonathan. He added a couple things, so that's where the design came from. If you're actually asking about who actually fabricated the board, well, I don't know, Jonathan. I think you ordered the production of those boards.
Right, yeah, so the production itself is with the GLC PCB in our case.
Okay. So yeah, generally the way this works is we use PCB CAD software. It's called KeyCAD, and you design the the schematic and you design the board and you lay out and you place all the traces and everything and you set just how it's going to be. That software creates some files called Gerbers that you then send off to a board house usually. There's a bunch of them. JLC PCB is one. They're in China. You send off the files to them, you pay them, and in probably like 2 weeks or so, you'll get back a nice stack of boards that's made almost exactly the way your design files said.
Okay, so let's move ahead. I would say we just put in one or two more. I do see that we have the D1 on the right side.
Yeah,
I do
D1,
have-
Y1 is gonna be straightforward chips to install, so you can
Yeah,
go with those.
sure.
They're easy.
I just don't want to extend the stream too long to get the people holding on to this too long. So let's see. So this one does not really have any sort of orientation, or does it? Because what I do see is some sort of a small line on the left hand side, and I do see one point on the board. So is this some sort of orientation or not for the D1?
No, that's not a orientation point for the D1.
Okay, so we just put on some.
Yeah.
Just put on some here, some here.
Sorry, I missed that question. That the D1 definitely has an orientation. There's a line on the board there, and there's a line on the part. You need to make sure you get that the right way.
So there's a line on the board and a line on the part. So do you see?
There's
Let me.
a vertical line there next to one of the pads.
Yes.
Yeah. So when you see that vertical line on the chip there, you need to make sure those are on the same side.
Ah, okay. So I had it on the right orientation. So let's see if if you can see this on the camera. So there you see there is this line on this IC. It's on the left hand, and we see one like line on the board here, and we need to orient it in the same direction, like so. Correct?
Yeah, that's it.
Okay.
I meant that white dot on the right is not for orientation. My bad.
Okay.
Oh, yeah, that is confusing. What is that dot for?
There we go. I really hope that the quality is kind of okay. So it seems like it's sorted on it perfectly. So just to have another big one, let's go to the front side maybe and put on the C28, this one here. I do know that this one has some sort of an orientation, so I guess the red on this here is the plus side, the positive side, and the other side is the negative one, so I would solder it on like this, right?
And you should see a white spot on the. Oh no, you don't see it on this one, but you can see it just with the way it's shaped. Also, you can't go wrong, right?
Yeah, it's kind of confusing on capacitors like that. Those are called electrolytic capacitors, and usually that line denotes the negative side.
So what line?
So it's the other way around right now. Yeah.
So I'm holding it the wrong way. So the red side should be on the negative side, right?
Yeah. You can also see that the positive side has the corners cut off.
Yeah, I see. Let's put this in the camera. Let's put this upside down so that we can see this.
Yeah, that's it.
All right. So we do have some corners on this side, and if we turn it around, we see that the side is with the red, and this is so the negative one, right? And I also
Correct.
see, okay, this is amazing. I also see that the corners are cut off on this white line on the PCB. So it's basically like Lego.
Exactly.
Amazing. So let me move my camera a little bit so that I can. There we go.
And one more thing you might want to note, and it's a trick. If there's a way for you to eat that part from under the board, that would be easier and better. One reason for that is your capacitor under it has some that plastic black part,
Yeah.
and the connectors just on the right of that part is also some black plastic connectors. So when you come with your heat gun, if you don't have a proper orientation, you might actually damage those. So heating from under the PCB, so you heat really the PCB under the capacitor, and the heat is gonna traverse through the PCB and bring to that shiny silver state still. So but you don't want to hold the PCB in your hands while doing that. So if you have a third hand or something to do it, that would be best.
Yeah, let me see. I do have one. Let me see. Wow. 1 second. There we go. And now I just try to do this from underneath. This looks a little bit stupid, but maybe it works. This third hand.
Really under, not like go
Yeah.
really under with it. Yeah.
Yeah. Let me try to move this a little bit up, because the surface tension should be high enough that this shouldn't fall off, right?
Not sure because you still have some weight on that capacitor.
Okay, let me see. I try to do it. Well, 1 second. I need to do it from the back here. Oh, okay. Now it's flowing away. Okay.
Yeah.
I see.
Yeah, so you're gonna want to have it a bit flat or to hold it with your tweezers, but that's gonna be a bit more tricky.
Yeah, let me try to do it with my tweezers. I'm shaking a little bit. Whoa.
That's the tricky part.
Yeah, okay, this is really tricky. Okay, wait 1 second. I need to do this in another way. This is not gonna work for me.
If you have if your desk has some hedge, you can also like put the Bitaxe holding on the edge of your desk.
Yeah, 1 second. I need to get this off camera. I'm sorry for this right now, but let me see if I can get this done. Okay, I'm trying to solder it right now. Okay, seems like it worked. It's not.
Looking good.
Yeah, it's kind of silvery. Oh no, it didn't. Interesting.
Yeah. When it's still if it's still out there.
No, it wasn't
Yeah.
really hot. No, it's not.
Oh no.
It's
Yeah.
not that hot. Okay, I probably need to get the paste off and do some new paste on it.
Oh, that paste should be fine.
You think so?
Yeah.
Oh, I see.
See?
I see. Yeah, but I need to put on a little bit new. Just a tiny amount here and a tiny amount here.
And maybe since you're doing under the board, you can put a bit more heat on your heat gun because the heat has to go through the board to the solder paste, right? So it
I
can, first
see.
of all, take more time, and second, more heat.
I see. This is kind of tricky, but it's also interesting at the same time. Like, you need to figure out, should you try to solder this with a heat gun from the top or not? Because otherwise you could probably damage a capacitor.
And for that, there's nothing better than trial and error and putting your hands on. So what you're doing is exactly the best way to learn is put your hands on.
Seems like now it's getting a connection. Could I damage the PCB with too much heat?
Yeah, obviously, that's a possibility. But if you go and you do it carefully and you look how it goes. When you see it, start to discolor, it's a hint that the PCB is starting to get a bit too hot.
Okay, let me see. Seems like it worked. I was a little bit worried about the position of this one, because I see on the bottom side of this there are some small resistors and stuff like this. Yeah, it's solid on. Okay, nice.
Very good.
Yeah, so basically now the process would be to do all the things that we did with what's left in here. So we have some, we have a crystal. What is this crystal for, actually, if I might ask this?
There's two crystals on this board.
Yeah.
I think I saw that was the 2-pin crystal.
That's the white one, yeah.
Yeah, so that's actually a real-time clock. So it's 32 kilohertz. That connects to the ESP32 and gives it the ability to track, like seconds very accurately, like wall clock time.
So, and does this have an orientation? Probably, right?
No, that one doesn't.
Oh, interesting.
Yeah, there's another one that has 4 pins, and that one is gonna have a small dot on it.
So the
Yeah.
U1 is an oscillator.
Yes, there
Yeah.
you go. That's the oscillator. That one has a polarity. You should see a dot on the top.
Let's see.
And that one is actually
Oh yeah, I see.
provides the clock for the ASIC. It's a 25 megahertz clock that drives the ASIC.
Interesting. So, I'm not sure. Should we progress and try to solder on more parts, or should we call it a day? Because we already streamed for 1 hour and 40 minutes.
It's really up to the viewers in my mind.
Yeah, I'm fine for another 20 minutes if you want to keep going at it.
I would say we could keep going with the U1 oscillator and maybe the Y1. And
Yeah, Y1 is the easy one. You can go with this one first, I'd say.
okay, let's see. Where is the Y1? Ah, there we go. I found it up here. Okay, let me zoom in there. Let me zoom in there. So there we go. We do have this Y1, and I put on some solder paste. A little bit on this side. Well, that's a little bit too much. And a little bit on this side. And so we don't have any orientation on the crystal Y1, so I can just put it on here, and it should be able to eat it right away.
Yep.
Okay, let the heat gun heat up really quick. There we go. Let me see if I can.
Miguel Ortiga is saying, nice job, congrats.
Amazing. It seems like it's not perfectly, like it's not really perfectly. If you see there is, it's a little bit, it's not really flat, but it's connected.
Yeah,
It should work.
better apply a bit more heat though, I'd say.
A bit more heat. Okay. Seems like I
Yeah,
got
yeah,
a
yeah,
little
and
too much of the solder paste on it. So let's try to put on a little bit more.
Better to have it sit there.
Okay. Should I apply some pressure with my tweezers?
You can always put a little, very gently, a bit of pressure, and you could see like the soldering coming on the sides. You can leave as is. It's just gonna create a small like shiny blob, and that's fine like that.
We can see the blob on the left side now.
Yeah. Perfect.
There. Okay, so Y1 is soldered onto it. So U1, the actual oscillator with the orientation, should... Let's see if we can see this in the camera. We do have a small dot, let's see, down there. So it's not really a dot, it's, I don't know. Yeah, it's some sort of a dot. We need to put this dot on. Here, let's get the board in the right orientation. Let's see, where do we have one? So we do have a dot right here. So I need to put this in the right orientation. Let's see a little
You want to
bit.
be careful with the also the components that are around this one because you can see there's two little, really little components around that part. So
Yeah.
C1 and R2, you want to be very careful if you make a manipulation not to hit those.
Okay, so should I reduce more of the airflow or should I just be gentle and try to... Maybe I should put on some flex on the other ones, I'm not sure.
Oh no, I would go just that way, but keep that in mind. So be very gentle. Try to
Alright.
apply again. Put your part. You can center it before applying some heat. When you're comfortable with it, you go ahead and apply some heat. When you look at some other YouTube videos with professionals, you see them eating at the same time that applying, but they're used to it. You can take your time, no problem, and then apply the heat.
Alright, so I kind of lined it. Let's see if it gets eaten. A little bit more. Yeah, to be a professional in such a thing must be a hard road of progress doing in this kind of work. Like I'm shaking all the way.
Yeah, I can't drink too much coffee when you're doing that.
Yeah, let me quickly zip something. Right, so we got a couple parts on it, and there are a couple parts left. So the U9, we also have the U10, and of course the ASIC. So what would you suggest for the ASIC? Let's quickly talk about the ASIC, because I think this is the last part that is actually different from all the other ones, because all the other ones have legs or some orientation on the bottom side. So would you suggest to just make it as we did with the previous ones, just make a line on both sides and a little bit in the middle, and then it should eat in the right orientation? Or how should I try this? Because of course I want to make sure that I have a proper connection on it.
So when you're the ASICs we send, they're pre-tinned because it's a bit tricky to tin, and also we use recycled chips that we test everything. So since the chips are already tinned, you don't want to apply your solder paste and just go and eat. What I would do is apply a little bit of solder paste, have your pads and your legs become shiny, and make sure there's no bridge, and then apply some flux and install, and let the heat do its job again.
So it should just apply a little bit of paste on the PCB,
Yeah,
heat it up, and then put on the ASIC if I see there's no bridge.
correct.
Okay.
That's interesting. I was just looking at some like repair manuals for micro BT Watts miners, and they had an interesting tip in there for repair people that was to do exactly what you said, to apply the paste to the chip, heat it up and make sure there's no bridges, and then apply the paste, like a little bit of paste, to the pad, heat it up, and make sure there's no bridges. I thought that was interesting.
So in our case, we just figured out the hard way, but good to know. Good to know. MicroBT is actually giving that advice.
Yeah. Yeah, I'd never even tried that before. I always just, try and do it the same way where you put the chip in the, the wet paste and hope for the best.
Yeah,
And
actually, you need to hope for the best because you don't know what's going on underneath.
Yeah, these are so hard because you can't see the pads. Once you've soldered on there, you can't see it, and it's just you have no idea what went wrong.
Maybe I'm biased because of the ASIC repairs, and we've changed so many of those. But I find this is one of the easiest parts to install.
Oh my gosh, you're a legend.
Interesting. So let's see, I will heat it up.
Make sure to apply some on your ground as well. Your pads, not just the legs.
Okay.
Yeah. Because this is where I would say your power for the chip is coming from. 1.4 volts is coming from there.
Okay. Yeah, I think there is a lot of potential for doing some sort of an repair shop for Bitaxe. Because this is really tricky to do, and I guess not everybody can do this. I mean, like from the capability, I see myself shaking here right now, and do this professionally. I'm not sure if I could do this.
Well, first of all, you get the hand over time when you train, and second, like even us, some days are going to be better than others. Some days we really have the shake, and we have a bad day and we get no repairs. Some other days we get like 30 ashboards fixed in a day. So it really, it's again, it's part of the process, and some days are better than others. But you'll if you practice, you'll get the hand of it.
So let's see, there are two blobs.
Yeah, let the balls cool down on the PCB, and you're gonna be able to grab them.
Yeah.
Cool, let it cool down. Actually, let it cool down instead of eating.
There we go. Okay, so I'm not sure. Is this too much for the ground and the positive?
But you would prefer to have it all leveled. So right now, if you apply your chip, it's gonna be all unbalanced. So it's gonna be trickier to make sure the soldering goes well.
So I should try to remove a little bit, right?
Well, what you could do, you could apply some flux, use your iron, and simply come and like spread it all over the pads there
Mm-hmm.
to get it even.
Okay, let's see. So let me quickly wait for my iron to heat up. This is really, I don't know, like the equipment that I have, I bought from Amazon and AliExpress. Like the soldering iron cost me $5, and the uh, heat gun costs, I believe, like $15. So this pretty cheap stuff I have here, nothing professional. But it seems like it's working.
Yeah, it will do the job. What's your iron temperature?
Currently at 300 degrees.
Okay, not too bad.
That center pad there, that big ground pad, is designed to remove heat. It's designed to dissipate heat, and so that's making your soldering job hard because solder doesn't want to get as hot as it needs to be to actually get smooth and reflow.
So now I'm just trying to see that I have some sort of an orientation. I have a smaller part and a bigger part, and try to align this on this PCB, right? So just try to align it like this. And then I just apply some heat and hope for the best.
Yeah, but before doing that, look really. You have can you see on the corners? You have those white lines there.
Yeah.
Those are guides. So you can use those guides to really align your chip, and that's the important part. If you got the chip properly aligned, you put heat. I guarantee you, the job is done.
Okay, let's see. With my small shaking hands. 1 second, let me get this away so that I can see it better. It's like really, I'm just touching it and it's moving way too far away. This is insane. But on the other side, I really find this is funny. It makes fun to do this, like getting used to it, doing this for the first time. We really need some workshops for this here in Europe. Couldn't you come over?
Oh well, that would be my pleasure, man. Actually, that would be my pleasure too. And I'm looking into some European conference for next year, actually.
So I believe I have it kind of aligned, correct? Let's see if I can. Maybe the corner down here is a little bit. Yeah.
It's from my point of view, it's looking good right now. So maybe go ahead and try that.
Yeah, I will try that. Let's see. And by the way, I do see that the top part of the ASIC is there's kind of some solder paste on it. Is it actually solder paste or what is it?
Yeah, that's well, solder paste. It's tin, but yeah, it's previously solder paste that. So you only have that tin remaining there, but yeah, it is. So it's those chips, the BM1397, they're copper plated, and they've been having such a bad rep, and I think right now you have the S19K and the S19J Pro Plus that actually showed people what I've been telling for the last 3 years, that the copper plating is not really an issue. It's so maybe to put a bit more context into that. The 17 series from Bitmain had some really bad issues where the heat sinks would fall off, and a lot of people associated
about
that
this.
with the heat sinks being soldered on top of the chips. But really, to me, that wasn't the issue. And what I found out through doing those repairs over time and having, our repairs still hashing and very, very good hash rates, it's really not a matter of copper plating. It's really a matter that Bitmain, because once we started to receive some of the new machines that never hashed, remove the heat sinks and see that under you didn't even have a grain of rice of tin. So all the rest of the chip was the copper exposed. And that copper, I don't know the exact chemical reaction that's happening. I call it delamination or oxidation, but it's like the copper is cooking instead of, because it's not transmitting the heat. And when it becomes too cooked, well, obviously it peels off and the heat sink would fall over. But when you have a properly tinned chip like this one, you never have issues. Copper is really a good way to transfer heat, and it's actually one of the superior way to transfer heat from the chips.
Yeah, that's pretty good to know. I do have this heatsink from you guys, but so I was thinking about this. I still need to use some heat paste on this, right? So I do have this.
You mean thermal paste? Yeah.
Thermal paste. Yeah, I'm sorry about that. So I still need to apply some on it, but they used some sort of soldering for
Yeah,
the
correct.
cooling. Okay.
And one thing I use your stream to also bring to the community is a lot of people think thermal paste is so they'll want to apply a lot of thermal paste, and with a minding that more thermal paste is going to create more cooling, but actually more thermal paste might create more heat in some cases. The thermal paste role is not to to cool nothing down. The goal of the thermal paste is to fill the micro cavities that are between the two materials that are cooling down your chip. So the what we call thermal interface materials, they're touching together, and there's micro gaps in between, and there's air that gets stuck in those micro gaps, and that air is not conductive, is an insulator for heat. So it really is all about getting rid of those hair micro pockets. It's not about applying a lot of thermal paste and using that paste to transfer heat.
It's kind of the same if you apply some thermal paste on your CPU and applying the
Absolutely,
coolant.
because there are
Yeah.
small micro imperfections you cannot see with the eye that's
Yeah.
going to create those micro pockets of hair and keep that heat inside the CPU.
Yeah, that's why you couldn't really use a CPU and the CPU cooler without some thermal paste. You could, but the thermal would be way too high to operate on a good amount of operations. So you have those those gaps that you explained. Yeah, okay, I understand this. It's good to know. So I think for today I don't want to bother you guys any longer about this, because now we have like 2 hours of stream, and I really appreciate both of you staying here and bearing with me doing this. I think it's really amazing, and really nice to do like this work, this soldering process, and I really
Well,
appreciate that
I
I
really
had
want to
both of
stress you
you.
did an awesome job.
Yeah, thank you. All
Yeah,
right.
that was an amazing first time.
First time for me ever doing this. It felt good. It really felt good, and I really appreciate it. So I will do the rest of the ICs off stream, and as soon as I have these done, I will try to apply the software on it, and I will let everybody know if it is working or not. Because I guess that's why we are here, right? So
So
Yeah,
yourself and anybody watching, anybody having the kids, first of all, thank you to all of you. Thank you for supporting us. And if you have any issues yourself or your viewers, don't hesitate. You can come over to our support. You can write to Decentral at support@decentral.tech. You can come to our website. We also have a phone line. We can do one-on-one calls, video calls, and you can just go on Twitter at us, and we'll help you in any of those platforms.
that's pretty amazing. Any last words from you both?
Scott, go
uh,
ahead.
yeah. I mean, this. Thank you so much for inviting me to be part of this. And like I think, like what Jonathan said earlier, this is a huge way to contribute to Bitaxe and open source mining is to be putting together these videos, how tos, getting the word out there, getting more people involved. If there's someone on the fence who thinks they can't do it, maybe now they think they can, and that's exactly what we want to do. So thank you for doing this. This is fantastic.
I really appreciate it. I love doing this, and I really love to spread more of the Bitcoin culture to the public. That's really what drives me. One thing I need to interrupt here is I see a comment about the hacks. Would it be possible that you just give a quick, short, brief look of what the hacks is? Just
Yeah. So
for the end of the
yeah,
stream.
yeah. So the hex is the next Bitaxe project, and the hex is going to be 6 chips. So this Bitaxe just has a single chip on it. The hex will have 6 on there, and that's a pretty important development. It sort of unlocks the designs and everything so that we can start making miners that have more chips. As a reminder, the ant miners have 100. They'll have hundreds of chips in there, and so we obviously don't want to remake those because Bitmain does a good job at doing those. But to do slightly higher hash rate miners to get more and more chips in there. So yeah, that's what the hex is. It'll be a design that shows how you can interconnect multiple of these ASICs together on a single board.
Yeah, amazing. This is the bigger goal, to get not just one tiny ASIC running, but a couple, and have this running at home at a low energy rate. This would be amazing. Like imagine
Yeah.
having a few hundreds, even a few thousands of them out in the wild, and they're just hashing right away, and maybe producing a little bit of heat for your bedroom or something else.
Yeah. There's so many different applications, and it's exciting to see what people are starting to do with it. And I think the hex and having more chips will kind of allow, hopefully, for more different applications in heating, stranded energy, all sorts of different applications like that.
Amazing. So I see from Gideon Vames, one last questions. Also, will it be 6 times more expensive? I think I can quickly answer this. So there are probably a couple more ICs and of course 6 of the ASICs that you need to place on a PCB. So I wouldn't say that the manufacturing cost of a Bitaxe hex would be 6 times as high or 6 times as high as the Bitaxe that we currently have, but it would be a little bit higher, like maybe 20 to 30%. I'm not sure, but it wouldn't be expensive. Like it wouldn't be really more that expensive, right?
Yeah,
You can
that's
expect
exactly right.
Yeah, 20 to $25, an ASIC, so you can expect at least that times five to be added to the total cost. But you're right, the manufacturing cost is going to be essentially the same, and that's the beauty of it, is that when we started the stream, we said if it can be connected to pooled mining, and it can. But as I've mentioned, with just one ASIC, it's going to be a bit harder to have a decent ROI on that, right? So with six chips and six of the latest gen chips, it starts to that data starts to get interesting.
Yeah, we are looking forward for this, and I really can't wait to see the first Bitaxe hacks in production or in actually hashing it right away. This will be amazing.
Yeah, it's coming. It's going to happen. We're getting there. There's definitely some additional challenges that come with having more chips all chained together, dealing with the power and the heat, and but yeah, if you can check it out on GitHub and see where we are with the design. Also on the Open Source Miners United Discord, you can follow along or get involved with the development of that. But yeah, it's coming soon. Stay tuned for that.
All right. I think those are some good words for the end. Thank you both for being here. I really appreciated it, and I really had fun doing this with you. Thank you guys who all joined in and watched this. So thank you guys, and see you on the next one.